So good evening guys. Today we are back with a very amazing problem statement. Today's problem statement is based on arrays, and usually I start my day by showing you the question and then the problem statement, but today I don't want to do that. I just want to come back and just want to show you exactly what is there in this problem statement. So this problem statement is very interesting problem statement. This is going to clear your concepts on arrays. It is going to clear your concepts on time complexity and how you can effectively solve problems which has hidden test cases and time complexity based issues. As the placement season is starting, I would like everyone to focus on DSA, focus on the coding, focus on the basic fundamentals like arrays, strings, recursion, and all those stuffs. So today's problem statement, I'm going to write a short title of the problem statement: swap pairs make sum. Okay, so this is all about today's problem statement. After that, we are going to describe on what type of problem it is. So it comes under arrays. Okay, and we are going to discuss two approaches. Okay, so be very careful. Okay, so let's first see the question. So first, there will be two sides of the arrays given as input. Okay, so I can write it like this as m equals to 6, n equals to 2. Okay, so initially there will be one array ARR of 1. It will have 1 2 3 4 5 6 elements. Okay, and there will be another array ARR 2 which will have 2 elements, 1 and 2. Now I have to check some condition. So the conditions are that the sum of all the individual elements has to be equal in both the cases. If so, then return -1. If not, we have to do some pair shuffling in order to make this sum equal. Okay, so here comes the interesting question. So if you suppose, for example, if you add all the numbers in the array 1, so sum of all numbers in 1 is how much? 3 4 5 6, and then it comes like, if you see, for example, it's 10 and 15, and then after that you will have say for example it is 10 15 18 9 20 21. Okay, so in the first case the sum is 21, and in the sum of all the numbers in the second case, if you see, it's just 3. So is there any possible way these two sums look equal? No, these two sums are not equal. Okay, so I can write over here as not equal. Okay, so and also, is there any possibility that you put or you exchange any two values from these two arrays to make the sum equal? No, that is also not possible. So let's dive into the problem and go in depth. So let's check the example what they have given. They have given the example as 4 1 2 1 1 2. Okay, I'll just write it over here. Array 1 as 4 1 2 1 1 2. So you can see there are 6 elements. Yes, there are 6 elements. 4 1 2 1 1 2, and the next array is 3 6 3 3. So if I take array 2, it will be 3 6 3 3. So now let's do the sum of the arrays. So sum of ARR of 1 is equals to 3 7 8 9 11. Okay, so if you just check once more, 3 4 5 6 7 11, I'll just check. Yeah, sum is 11. For the second array, sum of ARR 2, if you check, it is 3 3 3 9 and 15. So you can see the first array is larger in length, but the overall sum is lesser. So is there any possibility I can swap two values and make this array sum equal? Yes, I can do this. But how am I supposed to do this? So first, initially I have to check this sum. Okay, so if I see I have a sum difference, so I have to calculate. The first thing comes in mind, how will I make this sum equal now? So I have to calculate the sum difference. So the sum difference can be 15 minus 11, which is 4. Okay, so if I swap such a way that the sum becomes equal, say for example over here there is a value called 4 over here, and if their value is 3, so if it is 3 over here, what can be the total sum? So it can be 3, 4, 5, 6, 7, 8, 9, 10. And if I have 4 over here, what can be the total sum? 10. It is also not satisfying. So let's just try something else. So if I transfer this 6 to some place over here, so say for example what they have given in the question, that if we swap following value 1 in and 3 from B, so 1 and 3, so what is the just let me check one second. They're saying that we have to get the same sum. We can swap values 1 from A, okay, so values 1 from A and with 3 from B. So what is the third value? Which is this one. Okay, so if we suppose swap this, what can be the sum we get? It can be 3, 4, 5, 6, 7, 8, 9, 10. Okay, the sum is coming 10. If I give 4 over here, 10, no, it is not coming. So maybe they are starting with the 0th index. So this is the one value. So they are talking about 1, 0, 1, 2, 3, and they are talking about this 3. So if this 3 comes over here and this 1 comes over here, the answer can be 6, 9, and 10. Okay, this is coming as 10. So let me just check what they are saying. So the sum of we can swap values 1 from array of first array and 3 from the second value, values 1 and 3. Okay, then the sum can be equal. Let's check. So if I check, if I just put 1 over here, so it can be 3, 1, it can be 3, 6 in 3, 6, 6, 9, and 3, 6, 9, and then okay, I can understand. So let's check over here in the second array. If you see in the second array, what you can see, n equals to 4. If we swap 6 from array of and 2 from array B. So let's take another example, 5, 7, 4, and 6. So if you take array 1 as 5, 7, 4, and 6, is it so? Yeah, 5, 7, 4, and 6, and the one next array is 1, 2, 3, 8. So array 2 is 1, 2, 3, 8. So it is saying we can swap from array 6 from array and 2 from B. Okay, so it is just saying interchange 6 and 2. So if we interchange 6 and 2, what can be the new array? So the new array sum new, I can write it over here as new sum as 5, 7, 4, and 2. 5, 7, 4, and 2, which is 11, which is 18. Okay, and if I check over here, the new sum new, which will become 1 plus 6 plus 3 plus 8. So I can see easily it is also coming 10 and 18. So this way we can make the two sums equal. But how will you get to know that which value to swap? Okay, so before doing that, we have to first do the initial sums. So sum A initial. So what will be the sum A initial? It is sum A initial will be 6 and 5, 11, 11, 17, okay, 18, 22. Okay, this is coming 22. Sum B initial 8, 9, 10, 11, 12, 13, 14. So if you check the difference, it is coming a difference of 8. Okay, it is coming a difference of 8. So the sum obviously in this second array is smaller. So what we can conclude from this, since the difference is 8, okay, and also you can check that the sum of B initial is lesser than sum of A initial, right? But now we have to check the difference. So difference has to be A minus B. So the difference will be 8. So obviously there has to be some value which we have to swap, which is lesser than 8 or equals to 8 in this new array B array, in order to make this sum possible. Okay, so now we have understood the problem, and now we are going to go with the algorithm part. Okay, so first what I have done over here, you can see is carefully we have taken a function, and everything has to be taken in long values because they have given somewhere in the question that maybe we have to take because m log n plus n log n. So you have to be very careful with the time complexity. So this is the time complexity. I will show you what is the theirs and everything else. So what you can see is, first we are taking a variable, as I told, some a and some b. We are running a loop from loop I counter, which is going till num means I counter, which is going till the arrays, and it is individually taking the sum of all the elements. Okay, so you can see it's a time complexity of O of n because it is taking the sum over here numbers. Now next what we are doing is, if the difference between the sum is odd, return -1. Yes, so what you can see is return -1 means if the difference is an even number, return -1. So is not equals to 0 means it's an odd number. Okay, then return -1. Or else what we can do is we have to do the rest of the process. So we are taking a target value, which is the difference. Now we have to divide the target value by 2. So you will ask me, Arnav, why are we taking the division of target value by 2? So I have told you over here that the difference is coming as 8. But if you closely remember the algorithm for binary search, so binary search, what it basically does is mid equals to left plus right minus left minus of left by 2. So in this way you get a midpoint of a particular array, and then you use two-pointer approach, a pointer which helps you decide whether the value will lie in the left side of the array or whether the value will lie on the right side of the array. So this is done using two-pointer technique in binary search. But now we are going to focus on this particular algorithm. So what we are doing next is we have to take the difference. So if it is, suppose the difference over here in my previous case was 8, so obviously that's an even difference, right? So I have to proceed with the next sequence of steps. But if it is not 8, if it is 7, if it is 3, then what I have to do? I have to do just return -1, because -1 is signifying that there is no such possible combination in which you can make the sum a possible sum or equal sum. So you can see that while calculating the target difference, the long target equals to sum A minus sum B divided by 2 over here we are doing. Okay, then we are sorting the two arrays in ascending orders by using the sort from the arrays.collection class. After that we are using a two-pointer technique where we have to calculate where a loop is running between the size of the arrays. We have taken a difference between individual elements with the next elements. Okay, so if the difference is equals to our given target, we are returning 1. Else if we are moving the pointer to the next element or moving the pointer in the B of the next element, and we are returning -1. Okay, so this is a very clear-cut simple logic. Okay, so what basically I am doing over here I'm doing over here. So I will just graphic, because in the way to understand arrays is by graphical representation. So if you see there are certain elements, say 1, 2, 3, 4 over here in array A. Okay, and in array B there will be say 1, 2, 3, 4. Okay, and there is also one of my target values. So my target value is, say for example, my target value over here is 4, 7, 9 and 10. Okay, so target value over here is 10 by 2, which is 5. Okay, now I'm going to check the individual differences. So -1, error of I error of I minus error of j is equals to 5 or not. If it is not, we are going to move to the next higher number like this. Okay, so what we can basically see that first time we are checking these two values. So first time the difference will be checked from these two values, next time the difference will be checked from these two values, and so on and so forth. Okay, so on and so forth. So I am going to do ARR of I minus ARR of j is equals to target. Then what I am going to return? I am going to return 1. If you see, I have done over here, if the difference, which is error of I minus j is the counter for the second array, B array, and if the difference is equals to target, we have successfully found the pair. Else if the difference is lesser than the target, we have to move in the larger array, which is in the first array, and if it is not, in the last case we can move in the B array. and finally return -1 if no such pair is formed. Okay, so this was all about the concept of running this problem. I'm going to compile this code. So you see, with the given inputs, the code is running. Now I'm going to submit this code. So you can see my code has passed 1210 test cases out of 1303. So it's like it has almost passed all the test cases. So if you see carefully, it has almost passed all the test cases, but it didn't pass the last few test cases, which are hidden test cases, because of the time complexity of this approach. So we have to again run this. Okay, we have to again run this. You see, now I've again run this particular program and now it has passed. I got the geek beat. But how is it possible? In the first attempt, it was not running. In the second attempt, it just happened like that. Sometimes it happens because of the GPU performance and stuff, but I'm pretty sure when you do it in your device, it will not happen. So what? Now what we are going to do is, we are going to do a faster approach, an easier approach, okay? So for that, this was the initial approach. You can note it down, you can save it or somewhere else. Now we are going to do the second approach, which is using the hash set approach or using hash map. Now I'm just going to quickly keep the second approach over here. So this is the second approach. The second approach is also very simple, but it is faster approach. Okay. So what the second approach is saying, that we will have a class solution. We will have values int a and b and m, which is the size of the arrays, and two different arrays. In the first one, we are storing the sum of the first element. In the second, we are storing the sum. Then we are taking a sum value, which is taking the target difference. If it is odd value, we are returning -1. Then we are taking a target. Up till here, everything was same. But next, what changes is using a hash set. So here using a set, which is hash set is basically using like a coordinate system. Okay, you are storing some particular value against some particular target value. So if you see in this case, we are using a num counter, and we are storing the elements of the second array in this set B, and also set B, we are also checking that the elements present in the set A, if the set B contains the present value minus target, we are returning 1. So it's the same thing, but less number of steps. And I'm pretty sure it is going to run very fast because we are using a hash set over here. So you can see the hash set application just got executed, and both of them are right. But first one was taking slightly more number of time. Maybe it because of the speed of my CPU or stuff. But we have to follow this approach where it is saying that we have to have the expected time complexity within m log n plus n log n. So both of them follows the criteria, but using a hash set stored the value, and it also effectively saves the space complexity. So this was about today's problem statement. I hope you enjoyed it, and looking forward to solve more problems on arrays.